Hi, I'm Kurt Engelbrecht, an Associate Professor at DTU Energy, and I want to talk to you about student projects on rock bed thermal energy storage. So first I want to show why we need electricity storage in Denmark, and this is the electricity consumption versus hour. And here we can see that this is Saturday, Sunday, and then we use the most electricity during the work week, and there's a spike in the morning and a spike in the evening. And now I'm going to show this is the renewable energy production in Denmark. This is for 2018. And you can see there's very little correlation between production of renewables and our electricity demand. And also here I'm going to show this was the hour in 2018 when there was the highest overproduction of renewables for the whole year. And it happened sort of in the middle of the night, I think 3 a.m. on a February morning. And you can see that just a day or two later, there was a fairly large underproduction of renewables. So the whole point of energy storage, electricity storage, is to take electricity from these periods where we have windy days and not so much electricity demand, and store them for these periods when there's an underproduction of wind energy. So how do these things, what's the business case? Well, here I show the electricity price, and then I've just sorted that on an hourly basis for the whole year. And you can see that in Denmark there are some periods where you have very low electricity prices, and then you have some other periods where there are very high electricity prices. So the idea is to just buy electricity when it's cheap and sell it when it's expensive. And if we look at these first, the lowest, cheapest 200 hours for Denmark, you can see there are about 50 hours where you actually get paid to use electricity. Then there are another 50 or so hours where it's free, and another 100 hours where it's very cheap. So this is the motivation for having electricity storage. So here's the concept for thermal energy storage in a rock bed. We want to store heat at a high temperature, 600 degrees or higher, in a rock bed. And then we're going to use that heat to produce electricity in a traditional power cycle, so in this case a steam cycle. And the round trip efficiency is fairly low, less than 50%. But the point is that it's a rock bed, so the price should be also low, which makes it a competitive technology. And this is our rock bed, so this is just a drawing of it. Here you can see half of it is under the ground, and you have a layer of concrete housing, then you have a layer of hard insulation, and then in here where you can sort of see this temperature gradient, that's the actual rock bed. And you have flow in and out. The unique thing about this system is that we have all of the equipment is at the top. Basically charge, hot air comes in the top, and then we pull it out through a straw sort of in the middle. Now I'm going to show a quick video of how this works. So the idea is that basically you start with a uncharged bed, which means it's cold everywhere, and you blow air in from this fan, comes in these tubes, and it goes down, so we're charging from the top, and eventually you get some temperature gradient where you have your hot air stored at the top, hot rocks stored at the top. Then when you want to retrieve that heat, you turn on a different fan. Air basically flows the opposite way, comes in the bottom, goes out the top, and you can recover that heat, and eventually you bring the bed back down to some low temperature, and you use that heat to make electricity. So we've actually built a downscaled version of this at DTU Energy, and this is the construction. Basically we had to dig a hole, we had to put a cage to reinforce the concrete, then we sprayed the concrete. There was a steel bowl basically that was put down, and that's to protect the rocks, or actually it's to protect this hard insulation. These look like just kind of regular red bricks. To protect that hard insulation from the rocks that can actually destroy those bricks under operation. Then we filled it up with rocks, and then down here in the bottom left corner you can see we filled it with rocks, put some insulation on the top, and connected all of our external equipment like the fans and valves and heaters. So this is what an experiment looks like. This is actual experimental data. So we're taking thermocouple measurements that we have inside our bed, and we can look at what it looks like as we charge the system. So here you can see we start at time 0, everything's blue, which means cold. And then if I hit start, then you can see we bring in the hot air from the top, and that heats up the rocks from the top to the bottom. And then on the right side here we have the discharge, and it's the same process in reverse. We're pushing cold air in the bottom, and we're retrieving that hot air from the top. And in this experiment we don't have an actual power production. We basically measure how much energy we take out, and then of course we can calculate how we can use that to produce electricity, or even use it for things like industrial heat or district heating. So what are the potential projects that you can do on this rock bed? Well, we can run some new experiments on the system and then do some analysis of the results. We get a lot of data from every experiment, so there's a lot of analysis to do. We can look at material properties of rocks and see, for example, how they're affected by thermal cycling. We can do an economic analysis of the rock bed, so we'll look at electricity prices over the course of a year and see how much money can you make from this system, how much would you be willing to pay for such a system. And it can be in Denmark or other electrical grids. Then there's also looking at coupling it to different sources and sinks of heat. So maybe we can find an interesting waste heat source, or maybe some process that needs this stored heat rather than just electricity production. But the good thing is that we're looking at a lot of different aspects of this technology, and so we're open and we're flexible to having different projects. So if you're interested in working on this, you can just contact me. There's my email address, and we can discuss what kind of project you can do.